For our experiment, we will be determining the value of gravity in meters per second squared. Theory: we will be using an inclined plane of angle theta. The cart will be measured using mg sine theta, and the mass hanging will be measured using mg. The equation is ma is equal to mg sine theta. Factor out the m's and get the reduced equation is a is equal to g sine theta. Rearrange for g to get g is equal to a over sine theta. Our variables, which are time, independent, and velocity, which is dependent. These variables are plotted on a velocity versus time graph, where slope is equal to the acceleration. Using our acceleration and theta, we can plug them into our equation, where g is equal to a over sine theta. The photosensor pulley is positioned at the top of an inclined plane. There are pads at the base to halt the cart's movement. The pulley is attached directly to the Pasco computer. The monitor shows our data and graph. We will be using weights with a mass of 0.02 kilograms to counterbalance the cart. A protractor is placed at the base of the inclined plane to measure the angle in degrees. The cart is placed at the top of the inclined plane. The cart is released and accelerates down the plane until it hits the padding. Results: after finding acceleration from the velocity versus time graph, we plugged it into our equation, g is equal to a over sine theta. However, g did not equal 9.8 meters per second squared. It was found that our acceleration was the source of error. When rearranging for acceleration, it is g times sine theta. With the known value of gravity, which is 9.8 meters per second squared, our acceleration should have been 1.7 meters per second squared. Conclusion: the variables we needed for this experiment was a acceleration and theta. Theta was measured using a protractor at the base of the inclined plane, while acceleration was found from a velocity versus time graph. Using the graph, we put a line of best fit through the points, and the slope equaled acceleration, which we then plugged into our equation. Our possible sources of error came from either a protractor or a coefficient of friction, which was mu, while our protractor only measured to 1 degree.